Okay, so for this video I wanted to talk a little bit about how to sketch reciprocal functions. We've actually done a little bit of this already. So I wanted to start by sketching, let's say we sketch, 2 minus, 2 minus x. So this looks something like that. That number there is 2, and so is that number. I'm just going to get rid of the 2's because they're going to annoy me. And then using that information, I would like to sketch 1 on 2 minus x. So the first thing I want to do is I want to draw an asymptote anywhere where the curve passes through 0, because I can't take the reciprocal of 0. Now if I think about other key points, so the reciprocal of 1 is 1. So right here, where the line is 1, the curve will be a 1. In this region here, the curve that I'm reciprocating starts at 1. When it gets halfway, it goes to a half, so it will double in size. When it gets halfway again, it goes to 4, so it will double again, and so on. And so you can see pretty quickly that it does something like that. And also you know down here, it's basically positive 0, so the reciprocal should be positive infinity, sorry. You can apply the same kind of logic over here to see that it looks like that, right? Here, I'm reciprocating 2, so I should get a half. As I get really big, I'm taking the reciprocal of really big positive numbers, so I should get a really small positive numbers. And then over here, the exact same logic applies, right? I should go through -1, because the reciprocal of -1 is -1. Here, I'm reciprocating very small negative numbers, so I should get very big negative numbers. And then as I get bigger, I should approach 0 here, because I'm taking the reciprocal of very big negative numbers, but I never go across. You might like to think about some other ones that we're going to draw tomorrow. So I think I'll draw this one. I might draw something like this, and I might draw this, and maybe we'll do 1 or 2 more. But if you want to have a bit of a thought before you come in tomorrow, they would be the ones to think about, and we'll probably do at least 2 of those. After that, we will be sketching power functions, so meaning we will be sketching fx to the power of n. So let's have a look at an example. What should I sketch? Maybe I'll sketch like y equals x squared minus 4 squared. So first thing I want to do, firstly I'll sketch x squared minus 4, and now I'll square that. Okay, so when I square 0, I get 0. So through here and through here, I'll pass exactly through. Now the key is that numbers like a half squared get smaller. Right? And this is true, any number here is smaller if its absolute value is less than 1. Right? If I square a fraction, the number on the top stays the same if you make it 1 over a number, and the number on the bottom gets bigger. So you're dividing by a bigger number, so the fraction gets smaller. So if I draw asymptotes there and there at 1, they're not asymptotes, are they? Sorry, they're guidelines. So in between, in this region here, I'm squaring numbers less than 1, so I should stay underneath the curve, and this is going to look atrocious. Over here, I'm squaring numbers bigger than 1, so it should say above the curve. So it should be kind of like a parabolic shape almost, but going under and then coming over. And exactly the same thing over there. In this region, I'm squaring numbers like -1/2, which will go to -1/4. So they are smaller, but they're actually above, because -1/4 on the number line, if there's -1/2, -1/4 is somewhere up here. and then I pass through there, and then I go bigger, down to minus 16. Alright, I'm just going to pause for a second. I'm going to get that up on Desmos, take a screenshot, and then put it on this. So hold on one second. So I believe the expression is that you should learn something new every day, and I've just learned something, or realised I was dumb, and that is that x squared is positive. So I've put here, you can't see, the green one. Oh, sorry, that didn't draw as I expected. The green one, take 3. The green one is the absolute value of x squared minus 4. So that will shift it up, and then the blue one is me squaring it. So in particular, if you look in this region here, and also this region here, obviously because it's even, there's 1, and you can see that the blue curve, which is the squared curve, is above the green curve, the not squared curve. And so, sorry, it's below. And so squaring makes smaller. And then everywhere else, you know, the blue curve gets much bigger than the green curve for numbers with absolute value bigger than 1. Tomorrow we'll also think about cubes and the like, but I just wanted to get you started on that. So you might think about what that looks like when you cube the function, for example. And maybe you could think about like sine x, that was really weird, squared. You might like to think about that as well. Alright, thanks guys, I'll see you in the morning.